Okay, so let's look at this next question. It says that a motor insurance company wishes to estimate the proportion of policyholders who make at least one claim within a year. Okay, so sort of a no claim discount kind of a problem. They wish to estimate the proportion of policyholders who make at least one claim within a year. Okay, from historical data, the company believes that the probability that the policyholder makes a claim in any of the given year depends on the number of claims he has made in the previous 2 years. So clearly it is not Markov, because the future value also depends on the past value along with the present. So it depends on 2 years. In particular, the probability that the policyholders who had claims in both previous years will make a claim in the current year is 0.25. Okay, so if we had claims in 2 consecutive years, the probability of making a claim in the next year is 0.25. The probability that a policyholder who had claims in one of the 2 previous years will make a claim in the current year is 0.15, and the probability that a policyholder who had no claims in the previous 2 years will make a claim is 0.1. Okay, so it basically depends on the last 2 years. So they're saying construct a Markov chain model identifying clearly the states of the chain. So now this is a bit complicated. Let's see how do we go about doing this. So let's define the state space first. So basically we are modeling the claims in 2 years, and then based on that we want the claim of the next year. So I'm keeping 4 states here. The first one is 0 0, that is no claims in the previous 2 years, and then the next state is let's call it 0 1, that is no claim in the first year and then a claim in the next year. Okay, then there can be a state 0 1 0. Okay, and finally there can be a state 1 1. Okay, so this means that there are claims in 2 consecutive years. So that's how you can actually create a model, and that is how you can define these states. Okay, now let's try to draw the transition diagram and the transition matrix of this chain. Okay, so we have got four states here. 0 0. Okay, you have got 0 1, you have got 1 0, and you have got 1 1. Okay, which is claims in both the years. Okay, that's how I'm trying to model this. So the last one is 1 1. Okay, so you have got these four states here, and you want to show the transition between the 4 states. Let's try to see what will they be like. So 0 0 means that I have no claims in 2 consecutive years. Now if I have no claims in 2 consecutive years, the probability that I make a claim is 0.1, in which case I will move to this state 0 1, that is no claim in the first year and then a claim in the second year, right? So I'll move to this state, because this means that 0 1 means that see, since this was the first year, this was the second year here, 0 0. If I make a claim in the next year, my claims for the last 2 years become 0, no claim in the first year, and then because here is a claim, I'm moving to a claim state, then a 1 in the current year, right? So that is 0 1. So this probability is 0.1. Okay, then and the probability of not making a claim, then I'll stay in 0 0, because it will still remain like no claims in both of the years, so that would be 0.9. Okay, makes sense. Now if I'm in 0 1, that is I did not make a claim in 1 year and then just made a claim in the last year, just made a claim, so then my probability of making a claim is 0.15 and not making a claim would be 0.85. Okay, so if I make a claim now, then I'll transition to this state, because since I had a 1 in the later year and I'll again have a claim, so I'll move to 1 1. Okay, so that's 0.15. And if in case I do not make a claim, then this 1 stays a 1 and I get a 0 after this, so that becomes 1 0. Okay, so this one would be 0.85, right? So that's how it functions. Okay, now if I'm in 1 0, that is I made a claim in one of the last 2 years. I made claim in the first one but not in the second one. If I do not make a claim, then I'll go to 0 0 because I have a 0 on the later side and then again a 0 will appear, so that will be 0 0. So this is 0.85 if I do not make a claim, and if I make a claim I'll go to 0 1, right, because 0 will stay 0 and then I'll get a 1. Okay, so this is 0.15, right. Now if I'm in 1 1, that is I've made a claim in both the years, then the probability of again making a claim is 0.25, so that is the probability of staying here, so that is 0.25, and not making a claim will take me to 1 will stay 1 and I'll get a 0, so 1 0, so, and this probability would be equal to 0.75, right. So this is how I can draw a transition matrix based on this 4 states 4x4 matrix. Okay, staying from 0 to 0 is 0.9. Okay, so this one is 0 0, this is 0 1, this is 1 0, and this is 1 1. Okay, same here. Okay, so 0 0, and from 0 0 I can go to being 0 1, right. So this would be 0.1, and then you have got a 0 and 0 here. Okay, and if I'm in 0 1, I can go from 0 1 to 1 1 with a probability of 0.15, and I can go to 1 0 with a probability of 0.85, right. Yeah, and these are 0 0. Okay, now if I'm in 1 0, I can either not have a claim and move to 0 1, which would be 0.15, and I can have a claim and then I if I do not have a claim, I'll move to 0 0, right. So that is 0.15, and if I have a claim, I'll move to 0 1, which is 0.85. Okay, and 0 0. Now if I am in 1 1, the probability that I make a claim and stay here is 0.25, and if I do not make a claim, I'll go to 1 0, okay, which is 0.75. Okay, and this is 0 0. Okay, so that's how you can draw your transition matrix here. Okay, now they're asking us explain why the Markov chain will converge to its stationary distribution. So for that, what the condition needs to be is that it should have a finite state space, first thing. So is the state space finite? Okay, let's see. So the conditions are finite state space, that would mean that it has a unique stationary distribution, and it will have at least one stationary distribution. So yeah, the state space is finite, it has 4 states. Okay, so that would imply that it has at least one stationary distribution. And then the second one you have, the second condition that you have is whether the process is irreducible or not. So can you get from every state to every other state or not? So from 0 0 I can go to 0 1, I can then go from 0 1 to 1 1, so I can go from 0 0 to 1 1, and then I can go to 1 0 as well. Okay, then let's see, 0 1 0 1 I can go to 1 0, I can go to 1 1, and I can go to 0 0 as well via 1 0, right. And from 1 1 I can go to 1 0, I can go to 0 0, and then I can go to 0 1 as well. And if I'm in 1 0, I can go to 0 1, I can go to 0 0, and then through 0 1 I can also go to 1 1. So this is irreducible, right? Since every state is eventually connected to every state, other state, it is irreducible, which would imply that it has a unique stationary distribution. Now, will it converge to its unique stationary distribution in the long run? That depends on whether it is aperiodic. Now, since it is irreducible, the period of all the states will be the same. And since state 1 1 and 0 0 are connected to themselves, their period is supposed to be 1. So all the states have a period of 1, so it is aperiodic. Right? So it is also aperiodic. So this one mean that it will converge to its stationary distribution. Okay, now let's see the next part of the question. So it says calculate the proportion of policyholder who in the long run make at least one claim at a given year. Okay, so we want the proportion of people who in the next year will make at least one claim, right? That is what we want. Okay, so that would be given by these two states, right? That would be given by these two states in which I make a claim in the current year. So if I make in the a claim in the current year, I am either in 1 because the later digit is 1, which indicates that I have made a claim in the current year. So I am either here, or I am in 01, which indicates that I have made a claim. So if they want me to make a claim in the current year, I need a sum total of these two probabilities, right? And that too in the long run. So first of all, I need to compute the stationary distribution. So let's try to compute the stationary distribution. Let's try to see that. So for that, I'll have pi p. Since this is p, the equations will be given by pi p is equal to pi. Okay, so what would be my equations for the stationary distribution? Let's try to see that. Okay, so that would be 0.9 pi 1 plus 0.15. Okay, no, not pi 1. Let's call these states as 0, 1, 2 and 3. Okay, let's do that. Okay, so 0.9 pi 0 plus 0.15 pi 2 is equal to pi 0. Okay, then you have got let's see the next one. So the next one becomes 0.1 pi 1 plus 0.85 pi 2 is equal to pi 1. Okay, and then the next one is 0.85 pi 1. This was 0.1 pi 0. Okay, then the 0.85 pi 1 plus 0.75 pi 3 is equal to pi 2, right? And finally you have 0.15 pi 1 plus 0.25 pi 3 is equal to pi 3, right? So these are all your equations, and you'll have to eliminate one and add the normalization property, which is pi 0 plus pi 1 plus pi 2 plus pi 3 is equal to 1. Okay, so I've already taught you how to solve these equations, which is pretty straight. You need to cancel out any one of them. I would recommend cancelling out the last one, and then you'll have equation number 1, 2, 3 and 4. Okay, now you need to express everything in terms of one variable. Take that to be pi 0, it would be convenient, or pi 1, whichever one you'd like, because in two of the equations you have got pi 0 and pi 1. Okay, so that would give you those things, and then you can calculate use this equation to calculate the values for pi 0 or pi 1, right? And then ultimately your values for the stationary distribution would come out to be pi would be equal to, let's see, so your stationary distribution would come out to be 0. It would come out to be 0.794393, comma 0.093458 comma 0.018. Okay, no, this is the same value again, 0.093458, and finally it would come out to be 0.018692. So this should be our stationary distribution, and if you get this as the stationary distribution, what I needed was the all the values which were in which had a claim this year. So this is 0 0, this is 0 1, this is 1 0, and this is 1 1, right? So I just need this plus this, right? So if I add them, this becomes 0. 0.112150. So that is 11.25% of people that have at least have a claim in the long run, right? So that would be your answer, and we are only taking these two states because they have a claim in the current year, so the second digit is 1, right? We are not bothered about what happened in the last year, we just care about the current year. So we're adding these two values, and that would give me 11.25%, which is the answer. Okay, so let's look at this another very interesting question. This is from CT4 April 2007. And this was the question number 6 of that exam. Okay, so let's look at this. So it says that all this a 3-state process with the state space ABC, okay, so there are 3 states in this, is believed to follow a Markov chain with the following possible transitions. Okay, so there is a transition from A to A, A to C, and you have got something from B to A and then B to C, and there are some transitions and some are not possible. Okay, that kind of a transition diagram. Okay, and they say an instrument was used to monitor this process, but it was set up incorrectly and only recorded the state occupied after every 2 time periods. Okay, so basically you know the probabilities after 2 time periods, and you want to you know the 2-step transition probabilities, and you want to estimate the 1-step transition probabilities. From these observations, the following 2-step transition probabilities were estimated. You have got these, and calculate the 1-step transition probability matrix. Okay, that's what we need, right? So that how do you go about calculating that? That is the question here. So 1-step transition probability matrix would look somewhat like this. If I interpret the diagram properly. Okay, let's look at this. So your P would be equal to, so there is a transition which is possible from A to A, so that would be PAA. A to B doesn't seem to be possible, that is 0, and PAC, it would be some quantity. Then you have got something from B to B itself, and B to A, and B to C. All these are possible, so it's BA, PBB, and P again from B to C, so it's PBC. Okay, and then you have got from C, you have got to PCC, you have got PCA, and you have finally got no, PCA is not possible, this is 0. Okay, so from C to A you have nothing, and you have got PCB. Okay, so these are the transitions that are possible, and that's based on this diagram. Okay, so I saw this diagram, I observed it, and I realized these are the only possible transitions. And now they've given me 2-step transition probability. So let's see what the 2-step transition probability matrix looks like. So P square is given. Okay, and if I try to see it, what does it look like? So they have given me PA2AA. Okay, so this probability is given 0.5625, and then you have got PA square B is given again 0.125. okay, and this one is missing, which can be calculated by deducting it from 1. So this probability would be equal to 2p p2 basically, it would be from A to C, right? So this one would come out to be, if you see it, 1 minus 0.5625 minus 0.125. So that should be equal to, let's see, this is 0.3125, right? So you can write 0.3125. okay, so that's your probability here. Okay, now in the second row you have got p square ba, okay, which would be somewhere here, 0.475. these two are not given, so you can't figure them out unless two of them are known. You cannot know the third one. And you have got pcc, which is 0.4. okay, and these are stars. okay, so if I try to figure out this matrix, how can I do that? Okay, so I need to go from 2-step transition probabilities to 1-step transition probabilities. So if I would have multiplied p with p, I would have gotten p square. That is something I know already, right? So p into p is basically p square, right? That is known. So if I multiply p with p, let's try to see this. So if I multiply PAA, PAB, PAC, P BA, PBB, PBC, PCA, CB and PCC with itself, then what would it lead to? Let's see. So what would each of these entry represent? Let's try to see that. Okay, so the first one is 0.5265, that is a PAA will be multiplied with something. Let's see how does it work. Okay, let's write both the matrices and I'll realize what it is exactly. PAA, PBA, PCA, PAB, PAC, PBC, PB, this is BB, this is BC, this is CB, this is CC. okay, so if you multiply these, you will know what is what. okay, so if I try to calculate the first entry, that's nothing but PAA into PAA, that is PAA square, plus PAB multiplied with PBA, okay, plus PAC multiplied with PCA. okay, these are the entries that are to be multiplied in the following manner, so that they lead to 0.5625, right? Right, but I know something here. I know that this entry is 0, that's given in the question. okay, so here this one becomes 0 and you've got this one as 0 as well. okay, so this is 0 and again that makes this 0. okay, these entries have already been given as 0 because there are no arrows corresponding to them. So this one becomes 0 totally. okay, so this one is gone and this middle one also becomes 0 because BA would be 0. So let's just write the whole thing and then write it as 0. So it becomes PACA into PAC, right? So here you have got PAB as 0, this is 0, and you have got PCA is equal to 0, right? So this is also 0. So this becomes PAA square is equal to 0.5625, right? Which would give you PAA. The value for PAA becomes root over 0.5625, which is equal to 0.75, right? Okay, now you know this value. Let's just write its value, 0.75, right? Now let's see other entries if I can figure them out. So if what other values do I have? I have the middle one. Here. So let's try to figure out the middle one, and that's complicated. Okay. Okay, so we know this, that PAA is 0.75 now. Okay, that's given now. So I can actually calculate PAC with the help of this, because that would be, because the first row has to add up to 1, so that would imply that PAC is equal to 0.25, because PAB is equal to 0, right? So this entire row, it becomes 1. So that's how you calculate it. So you have two entries now. Now the next thing is, let's try to see how it works out. Okay, so you've got these values. This one is 0.25 and this one is 0.25 as well. Okay, now if I multiply them, if I check for the second row, so if I check for the second column, okay, if you see that would be the 0.75 multiplied with the 0, then a 0 multiplied with PBB, and at the end you'll have BC multiplied with PCB. Okay, that would be 0.25 into PCB, right? So that would give me the entry for the second row and the first row and the second column. Okay, so that entry was given as AB squared, right? This was the entry, and this was given in the question as 0.125. okay, so this term, it becomes 0, this term, it becomes 0, so you have the value for PCB, which would be equal to 0.125 divided by 0.25, okay, which would come out to be 0.5, right? So you've got this as well. So your PCB is equal to 0.25 or 0.5, I'm sorry. This would mean that this PCC will also be equal to 0.5, because this last row also has to add up to 1, right? So this would be 0.5 and this one would be 0.5. okay, so you've got the first and the last row figured. Now you have to deal with the center one. So for this, I know the p square. In the p square matrix, I do know this value, which is the value for the second row and the first column multiplied, right? So I can actually multiply the second row with the first column in order to get this. So that would mean, let's erase this here and then write this. So this would mean that the second row and the first column, right? So let's multiply these two. That becomes 0.75 PBA plus 0. That would be PBA into PBB. Yeah. Okay, and finally you have got the third value here, which would be multiplied with the 0 here, so that becomes 0. So this thing has to come out to be 0.475, right? This value has to come out to be 0.475. So actually what you can do here is you can take the PBA common, and you can say that 0.75 plus PBB is equal to 0.475, right? So that is known. This gives me an equation, right? And this gives me an equation. So let's call this 1. Okay, this is one equation that I have, and this last known value of 0.4 will give me another equation. So this value is known, which is the which would be given by the last row into the last column. So that would come out to be, let's see, the last row into the last column. Okay, that would give me a value for PBC, right? So let's try to see that as well. So last row into last column would give me P. It would give me the last value, which is 0.4. So it would be 0 into 0.25, 0.5 into PBC plus 0.5 into 0.5, which would be 0.25, and this thing is equal to 0.4, right? This is equal to 0.4, right? So that would imply that PBC is equal to 0.15 divided by 0.5, which is 0.3, right? So I know the value for this one as well, for this last one, PBC, which would be equal to 0.3 now, right? And this is equal to 0.3. Now I need to figure out these two, and I know this row would sum up to be 1, right? So that is another thing which is true. So PBA plus PBC, PBB should be equal to 0.7 to make the entire row as 1. Okay, now I've got two equations. I need to solve them in order to find all of these values. Okay, so these are the two equations. This is equation number 2, and this was marked as equation number 1. So now I've got two equations in terms of PBA and PBB, which I need to solve. So I can, from 2 I can write that PBB is equal to 0.7 minus PBA. Okay, now let's replace this into the first equation. Okay, so that would become 0.75 PBA plus PBA into 0.7 minus PBA is equal to 0.475, right? So that is my final equation, and that would give me a value for PBA. It is becoming quadratic now. Okay, apparently, let's see, 0.75 PBA plus 0.7 PBA minus PBA square is equal to 0.475, right? So that is my equation here, and now I can actually solve it. That would give me what would it give me? Let's see. So this is 1.45 PBA plus PBA square minus 0.475, and this is equal to 0, right? So that is what I have here. Now let's try to solve this quadratic equation. So how do I solve it? Let's apply the quadratic formula. So PBA would come out to be minus B minus 1.45 plus minus B square, which would be 1.45 square minus 4 into A into C. Okay, so that would be plus into 4 0.475 into 1, right? So that is what I have here, upon 2A, so that is 2. Okay, so this would give you two values for PBA, which would be equal to, so no, this term PBA square was negative. Okay, so let's change this to be negative. Okay, So that would make this term to be negative and this one to be negative, right? Now this is correct. So PBA would you'll get two values for it. It's either 0.5 or it's 0.95. Okay, so these are the two values that you get, and you'll have to reject 0.95 because you know that PBA plus PBB plus PBC have to be 1 and all of them have to be positive, and PBC is already 0.3. So if you take 0.95, PBB would become negative, which is not possible. So you reject this. You have 0.5, which is your final value, and that's the reason your entire matrix would look somewhat like this, 0.5, and this becomes 0.2 because they have to add up to 1. So this is your answer. This is your final matrix that you have. Okay, this is your P, which you wanted to find. So this was a question for 8 marks. Okay, this is another interesting question from 2007 April, right? April exam, and this was question number 7 there, right? So this is the question that we'll be taking, and it's interesting, and I'll be solving it partially. I'll help you how to construct the Markov chain, but then you'll have to figure out how to make how to calculate the stationary distribution. Okay, and this is for 10 marks here. All of it is for 10 marks. Okay, so let's read it. So every person has 2 chromosomes, each being a copy of one of the chromosomes from one of their parents, right? So basically we know that when we talk about chromosomes that define the sex of a baby, one chromosome from each of the parent has to come. Okay, and there are 2 types of chromosomes labeled as X and Y, and a child born with an X and a Y chromosome is a male child, and a child born with 2 X chromosomes is a female child, right? So basically the XY is male, and that's something we know. Okay, that's male, and XX is female. Okay, so it's the second chromosome that determines the gender, right, out of this pair. Okay, a blood clotting disorder, hemophilia, is caused by a defective X chromosome. So X has to be defective in order for a person to have hemophilia. A female with the defective chromosomes X and X will not usually, now this they have denoted as X star, the defective chromosome they have denoted it as X star. So any female who has a defective chromosome X star and the other one is normal X will not usually exhibit symptoms of the disease, but may pass the defective gene to her children, so is known as the carrier. Okay, so females can only be carriers, they do not exhibit symptoms, but they can pass down the disease. A male with a defective chromosome, that would be X star Y, okay, so one of the chromosomes has to be defective, suffers from a disease which is known as hemophilia, and he is called as hemophiliac. Okay, and a medical researcher wishes to study the progression of the disease through the firstborn children in each generation, starting with the female carrier. So they are starting with the female carrier, and then they're going how the disease will progress. Okay, you may assume that every person has equal chance of passing their chromosomes to their children. The parent of each person in the study does not carry a defective chromosome. Okay, the partner of each of the person in the study, that is, only one partner will have a defective chromosome and the other one will not have, of course. So we'll only talk about the partner who has a defective chromosome. Okay, and there is no new genetic disorder that occurs, genetic defect that occurs, right? So show that the expected progress of the disease through generations may be modeled as a Markov chain, and specify carefully the state space and the transition diagram. So this is the trickiest part. Then the rest of the question is proving it irreducible and aperiodic, and then calculating the stationary distribution. This part you will be doing I'll just show you how to make the state space and the transition diagram, right? So let's try to see this. Okay, so the state space, if you see it, I'll define it with 4 states. Okay, let's make it have 4 states. That would be 1, 2, 3 and 4, right? So now there are only 4 possibilities here. A person can be a male or a female, and they can be a male or a female with the disease or without the disease, right? With the defective chromosome or without the defective chromosome. So let's write the 4 states as such that way. So it can be a male with the disease. So let's call him, since the disease is called hemophilia, so I'll call it MH. It can be a female who's a carrier of the disease, so that would be FH. There can be a male who is not a carrier of the disease, so that would be MN, and female would be FN, right? So you can write the 4 states as such. You can write as for example, the first state can be written as a male hemophiliac. Okay, so hemophiliac. Okay, and then you can write a female carrier, right? And then you can write a male non hemophiliac, and you can write this as a female non carrier, right? So you can have these 4 people here. So let's try to see how it works. Okay, so I've got state 1, I've got state 2, I've got state 3 and 4, right? And you have got 4 here. Okay, so let's try to see what the transition diagram will look like. So from 1, 1 is a, so you have to start with the female carrier is what they told us. So let's call that state 1, and let's call the male hemophiliac as state 2. Okay, so let's make this 1 and this as 2. Okay, so you're starting with the female carrier. Let's write 1, which let's call her FH. Although she does not demonstrate the symptoms, she just carries the disease. This would be MH. 3 would be MN, and this would be, the last one would be FN. Okay, so let's try to see how it works. So the question says that you have to start with a female carrier. Okay, so my first state at time 0, x0 is equal to state number 1, which is a female carrier, right? So for a female carrier, her chromosomes are XX asterisk, right? These are the chromosomes. Now what can happen? Okay, she can either have a male child, okay, or she can have a female child. So you can have either a male child or a female child whose probability is 0.5 in each case, right? Here now you can either transfer him X or you can transfer him X star. Okay, in which case, in this case he'll be a hemophiliac, in this case he won't be a hemophiliac, right? So either of the things, their chances are again 0.5 and 0.5, right? Again for a female, you can pass her X or you can pass her X star. So chances are again 0.5 and 0.5. In this case she will be a not be a carrier, and in this case she will be a carrier. Okay, so each of the chances, they come out to be 0.25. so from the first state, that is a female carrier, you can go to any of the states with a chance of 0.25. You can either be a female non-carrier, or you can be a female carrier, you can be a male hemophiliac, or you can be a female you can be a male non-hemophiliac. So let's draw a 0.25 arrow from every state to every or from this state to every other state. Okay, so that's how it will precisely function, and the reason is clear. She can pass on her X star, or she may not pass it. Okay, that's something that can happen. Now if I talk about a male hemophiliac, so his chromosomes look somewhat like this. So they are either a Y or they are an X star. Okay, so if he has a female child, now, then he will either he cannot give a Y, because in that case it would be a male child, so he'll have to give a X star only. Okay, and if he gives a Y, then it would be a male non-hemophiliac, right? So in that case it would be a male non-hemophiliac. Okay, let's draw this state there and that state here. So let's call this as 4, which is female non-hemophiliac, and this non-carrier, and let's call this as 3, which is male non-carrier, right? So now the transition diagram would look a bit better. Okay, so this male hemophiliac, if he has a female child, then she will definitely be a hemophiliac, because be a carrier, because he'll transfer this X star, and females are XX. Okay, so they cannot have a Y. So this probability becomes 0.5, and if he'll have a male child, he'll definitely transfer his Y. He cannot transfer his X, okay, because he has to give the Y. So that probability is 0.5, right? So that chance, it becomes 0.5. Now if I try to see from a male non-carrier, now a male non-carrier, we are assuming that his partner does not have that chromosome which is defected, so he has a XY. Okay, so he can either transfer he can either lead to a male non-hemophiliac or a female non-carrier. Okay, he cannot transfer this X star, he does not have it. So basically he can either lead to a male non-carrier with 0.5 or a female non-carrier with 0.5 again, right? So that's how it works. And then if you have a female non-carrier, so she can either lead to a female non-carrier with 0.5, or she can lead to a male non-carrier with 0.5 again. So that's what your transition diagram should look like. Now based on this transition diagram, you can do rest of the question. You can figure out the stationary distribution and everything. Okay, and you just have to remember that this female non-carrier, she has chromosomes XX, so she cannot lead to FH or MH, right? She cannot transfer an X star chromosome, so she'll only lead to a male non-hemophiliac or a female non-carrier, right? And here the chromosomes were XX star, so she could transfer the X star chromosome as well, right? So this is your transition diagram.